Adrian, the floor is yours.
All right, thank you, Mark. Welcome, everybody, and thank you again for spending this little time with me. The title of my session today is Blockchains Applied, Finding a Use Case for Apex. So earlier this year, I had to go through that yearly task of trying to figure out what abstracts that I want to submit to Kscope 18. And one of the tricks we kind of sometimes use is to actually feed in some couple of in things, couple of keywords that hopefully will give the reviewers a little bit of interest in what I was going to share. So I figured this might work with blockchains because I was told watching this episode of John Oliver's last week tonight, he was sharing about how a particular company in the US, they rebranded themselves and called the company Long Blockchain Corporation when really all they're doing is selling iced tea. And according to him, after the company was renamed, their stock values actually tripled overnight. And when I delivered this session at Kscope, I guess I was not too surprised to have almost half the room filled. And I got you guys here online to meet with me today. So it clearly works, right? But that really isn't what I kind of aim to achieve. And I hope that, sincerely that that's not the only reason why you're here today. While blockchain is a vast word, I think every time, as a technologist, you're probably familiar with, how every year we'll hear this hot new topic that came, that would get our interest. And I think it's due diligence that every one of us actually figure out what this technology actually entails, and size up what's good about it, what's bad, and most importantly, is it even at all relevant to us? Because that solution has to work for us, and so that's really the purpose of my session today. That's actually to introduce what the technology is all about. More importantly, how it's going to be, or help you kind of see for yourself how it might be relevant in your company or some project that you're embarking on. And finally, how you can actually use blockchains within your Apex solutions. So before I started proper, I just wanted to kind of introduce myself. So I work for Insum Solutions, mostly as an Apex developer, but in the last year and a half, I actually started morphing into a little bit of a DBA role as well. I personally started Apex in late 2010. Well, it's better late than never. I am a board member of the local Oracle users group, and as well a founder and co-organizer of the Oracle meetup group for Apex. Here are a couple of links that you can find me. I'm most active on the Twitter. I've got a couple of projects on Git as well, and I do blog occasionally. So a little bit about Insum. So we are a Canadian company. We were founded back in 2002, and we're primarily a center of excellence for Apex. We've been growing pretty well, and right now, as to date, we're probably one of the largest Apex consulting companies in North America. We have offices in Canada, down in the States, and Peru, and more recently we've begun to create some alliances across the Atlantic. We provide a wide range of services that involve Apex, so development, consulting, coaching, and staff augmentations. The other interesting thing that we kind of do as part of innovations is to create extensions to your other Oracle products, such as EPS. So if you're interested, do talk to us. Well, if there's anything we can help with, just feel free to contact us. So here's an outline of what we'll be discussing today. We'll begin with a very brief introduction about blockchains and what the enabling technologies are out there. I'm not a mathematician, and I don't claim to be one, and there are lots of detailed, in-depth introduction to what blockchain technology really is out there. And so as a take-home, you probably want to research on it as well. So I will give, a certain amount of introduction enough for us to kind of go on, because the focus today would be about us examining how useful it's going to be, and then look at a couple of use cases. And if I have time, I actually want to do 2 demos, but my experience at Kscope 18 is that I usually run out of time because there's just too much kind of share and to kind of lay the groundwork for you. So many of us, myself included, we kind of first experienced blockchains because of cryptocurrencies. Like the Bitcoin would splash on your screen every now and then. They were talking about how it's gone, skyrocketing in terms of prices, and how crazy people can actually get, and that's really true. But while Bitcoin is one of the most prominent out there, there are actually lots of other cryptocurrencies, and more importantly, I think that we actually have to know about the supporting technology that's driving Bitcoin itself. And this was actually first described in a 2009 white paper by Satoshi Nakamoto. I think to date, we still do not know who this person or these persons are, and probably for good reasons. It's blockchain backed, but most people just look at it as a way of trading value. So what is a blockchain? Essentially, it consists of a few things. The first and foremost, it's about a distributed ledger. So a ledger, as you might know, it's a way for people to kind of keep track of transactions. For example, things going out, going in. In banks, they use it a lot to electronically maintain how much cash I actually have in the bank, which is almost zero. But the key piece here is that unlike banking systems, it is based a lot on peer-to-peer technology. So everybody within the blockchain network would have a copy of this ledger. And in order to kind of make sure that we have the authentic piece of records, there is a lot of cryptography involved, where you have transactions being written to blocks, and these blocks will contain the hash of the previous block. So the idea is that, if you really wanted to fudge any of that data, you would have to not only change and rehash that particular block that you're interested in, you have to hash all subsequent blocks which are ahead. And the other way to attack the network, of course, is that if you had enough money to invest in compute resources, you could basically overwhelm the network and say that you have the authentic piece. And this agreement comes about by something they call a consensus algorithm. There are a couple of consensus algorithms out there. Bitcoin and the other popular one, Ethereum, relies really on proof of work. And proof of work these days, because it really just relies on the compute power, is just not making a lot of economical sense. And there are different variations of that, and but we won't really discuss that today. So also in the blockchain world, there is this notion of a public and a private blockchain. The other term for it, for public, would be permissionless. And you'll see examples of these. The prominent ones are Bitcoin and Ethereum on the right. These are blockchains that you don't really need to get any kind of authorization to join the network at all, and it's basically a free-for-all, Wild West kind of environment. But on the other side of the spectrum, you have permissioned networks. So Quorum is actually interesting. It's based on the Ethereum. It's currently a project that's managed by JP Morgan. So it gives you kind of a little bit more privacy within the within a blockchain network. And then you have some highly, I'd say, proprietary technology like Corda and Tendermint. Corda is actually, I think, one of the favorites with the banks as well. Today, we'll actually talk about Hyperledger, and Hyperledger is not just one product, it's actually a whole suite of products. These permission networks, although it says permission, the idea is that you restrict this not to just one organization. It may be a group of organizations that are trying to work together with a shared data source. So while Bitcoin seems to be what everybody calls the killer app for blockchains, I personally disagree, and I believe quite a number of people out there as well would disagree. I think the important thing about blockchains is actually smart contracts, which you get with some of the technology that's currently out there. Smart contracts are basically lightweight computer code. They run on other people's machines when certain preconditions are actually set. And these are generally useful for kind of helping with the transfer of assets, and we'll talk a little bit about those in the demos and the use cases. And there are a couple of implementations out there. I mentioned Ethereum. Ethereum has this thing, this language called Solidity, which looks a lot like JavaScript, but isn't JavaScript. And then Hyperledger Fabric, which is a specific product under the Hyperledger project, which is called chain code. And chain code, you can actually write them with different kind of programming languages. Right now, I believe Node.js and Go are supported in version 1.1. There are probably plans for a Java SDK as well, and probably Python, it being one of the more popular languages these days. Before I go on, many of you would have probably searched the keywords blockchain and Oracle, and I just want to kind of add in a side note that blockchain, Oracle actually, the two words actually mean a little bit different. You might get two different kind of search results. So the first one, of course, you're going to hear a lot about the autonomous blockchain service, which Oracle recently announced just a couple of weeks ago. But the other kind of results that you generally get is about a specialized role within blockchains, where because when things happen on the blockchain, they cannot rely on external information, so information that's in databases that are outside of the blockchain. Because if you're going to make a decision, then that information that you make, so those preconditions that you use to make a decision cannot change. And so there are these things called oracles out there, which they're actually products where you can then try and take a snapshot and maintain it alongside your transactions. So what do smart contracts actually do for us? They actually help, make this concept of decentralized applications possible. You might sometimes hear the acronym DApps, and that's what they are. They are autonomous applications, so they run completely without any form of control in that sense. They don't rely on any central pool of resources like databases and application platforms. So they run on client devices and interact with the blockchain, and blockchain in its nature would be a form of distributed storage. The apps are not standalone applications. They're generally for multi-user domains. And one really interesting thing about DApps, at least in the permissionless world, is that the code that's driving the application, the smart contracts are actually open source. And I'll actually show you a site later on where you can kind of examine smart contracts that have been published, pushed to the Ethereum network, and maybe it can help you, build your own next killer DApp. So I wanted to go through a couple of examples of DApps, but I wanted to bring back a little bit of nostalgia for me. So more than a decade ago, I worked in Singapore with a higher education institution called Nanyang Polytechnic, and we were pretty much innovation driven. And at that time, I was teaching final year projects, and I had students doing work in my lab. And I tend to like, to give them something interesting to kind of work with. And we were involved in bioinformatics, so you deal with things like genetics and all that. And we were encroaching into the Java mobile space, and I was looking at Java ME and how we could create a game where we could have Siamese fighting fish to kind of fight in inverted commas. And basically what it is you would have fish with different color, different fin shapes and sizes, and you would put them onto a huge screen, and two fishes would kind of compete by means of having users log in and voting the prettier fish. And why I kind of mention it is because today all this is actually possible in a DApp known as CryptoKitties. And it works fundamentally on about the same principles. You have each CryptoKitty actually has C attributes, and that C attributes actually defines its physical traits. So like, for example, the eyeball shape, the color of the CryptoKitty, the patterns that you have, and they have, I'd say, some aesthetic value. And like all products, how much you're willing to pay on a product really determines its cost. And that leads to the other thing about CryptoKitties. Yes, it has this concept of auctioning. So like the application I was talking about earlier, you would breed CryptoKitties, and you want to find the best set of parents. And in order to do that, you may actually have to buy it from somebody. And to me, this, maybe it's just me, I'm being cynical. To me, it's kind of totally worthless. Why would I pay Ethereum to kind of buy these CryptoKitties? But lo and behold, the last time I checked, one of these kitties actually fetched on the auction market a price of US dollars 140,000. So so think about it. I mean, it may seem like nothing, but to somebody else, it may actually mean a lot of money. So other DApps, for example, is role-playing games. I don't know if you guys have played things like Ultima, but from the old days, from a single-player application, they morphed into multiplayer online games, and they actually became a secondary market where people would trade certain hard-to-find items, maybe a pair of boots that had diamond studs that give you some magical powers. And people would do offline trading where you would agree to pay a certain price in dollars for the boots, and then you'll both log into, for example, Ultima Online, and make that exchange. But the drawback about this is like, so if I spend $1,000 on that pair of boots, then money is kind of gone. The only way for me to get it back in cash is that somebody else would see value in that and buy it over from me, and I get that $1,001 back, right? But what if before I could sell it, the company actually folds or decides that this game is no longer something that they want to work on? That means the $1,000 that you spend on a pair of boots just get washed down the drain. But in a DApp kind of scenario, that actually is very hard to, it's very hard for that to kind of happen, because the data is not being stored in and doesn't belong to one person. It belongs to everybody who's kind of involved in that environment. And as long as there are players, as long as there are people who are willing to look at that open source code and continue developing those applications on top of it, it's going to work, and you're still going to have value in that. So a little snapshot from May this year is just kind of listing like a stock exchange, how much gets traded daily. You would see that a lot of it is games. The others are probably exchanges where people trade other forms of digital tokens. If you are interested in learning Solidity, I would highly recommend this site. It's called Crypto Zombies, and it's a fun way to kind of learn how to write Solidity applications and just build something in the process. This Jojo here, it's me trying to get through level 1 of the course. So what drives all these smart contracts? A lot of my focus really is on Ethereum, which is made in Canada by, it was first written by Vitalik Buterin. He conceptualized the idea of an Ethereum virtual machine where smart contracts actually live on and store state on. They are largely driven by computational power, so people who volunteer their compute resources to help run all this Solidity code, and it's a mixture of running it off CPUs or graphics cards, GPUs, which kind of explains why in the past few years you would actually find that graphics cards are actually hard to find and tend to be a little bit expensive. If you wanted to start with Ethereum development, these are a couple of tools that you would encounter. So Geth is actually it's a Go-based application which allows you to run anything from a full Ethereum node to something that's lightweight. So there are different levels where how you actually run it actually determines how much network bandwidth and data storage that you would actually require. So as a developer, you may not want to kind of start with that because it costs quite a bit of money in terms of storage and your internet connection that's actually being used. There is a product that's under a framework called Truffle, and that's called Ganesh, and I'm actually going to use that. It's a personal Ethereum blockchain, so you are in complete control. It's just a single node that runs the blockchain. You get to determine how much Ethereum you kind of want to assign yourself, and everything happens just within that environment. So there is a command line, a CLI version available, which you can get through your Node.js channels. It's also available as Docker images, and a cute one is actually a binary download, which you can grab from their website, the Truffle website, and that allows you to run and monitor the blockchain itself. Truffle really is a full suite of tools, so it helps you build up a couple of skeletal code folders that you kind of need to get started with Solidity programming, as well as to help you compile the code and then finally to publish it to the blockchain. And you can choose to publish either to the main net or any of the developer nets available, including Ganesh. Just a couple of notes is that when you run any of these nodes, the issue is that they expose a JSON RPC which you kind of interact with your application. And the problem with that is that if you expose it to the wrong people with the wrong amount of APIs exposed, then you might find that you lose a whole wallet of maybe just 1 or 2 Ethereum, which could mean a lot of money. So just be careful of that. Don't expose that unnecessarily. Ganesh really, if somebody is going to steal my fictitious amount of Ethereum, well, so be it. So that's Ganesh running, and there's a couple of wallets that I have with each couple 100 Ethereum each, and you can see things like the the transaction that goes on and all that stuff. But I generally do not use this. I run it within a Docker container. So the other platform for running smart contracts, especially if you're from the industry and developing, real applications, Hyperledger is actually a project that I believe was started by IBM and a group of companies that had an early start to blockchain. It is under the umbrella of the Linux Foundation, and a lot of how they operate follows closely with the Apache Foundation. So if you know Apache, they are, they have products like the HTTP server, Tomcat, and all that. So they collectively manage the way things are kind of licensed and all the best practices. So they govern how projects actually run. But within this consortium, I'd say they came up with a few projects. The leading one is, of course, Fabric, which a lot of them provide as a cloud services these days. Hyperledger also has things like Sawtooth and Burrows, which are a little bit closer to Ethereum. Burrows actually runs in both a permission and a permissionless mode. There are other contributions like Aroha and Indy, but you hear a lot less of these, probably because it really depends who the big boys are and what they actually use. So a quick overview of what's involved in running a Hyperledger Fabric. And if you had the chance to listen to Emmanuel's session, he's from Oracle, and he's been talking a lot about the autonomous blockchain service that Oracle provides. And he had a session at Kscope 18. I'm not too sure if the recording's available, but it talked in depth about all the different projects and also about Fabric. But just a quick overview. So users would actually interact with the blockchain through an application that's typically built on top of an SDK. It interacts with the membership services, which controls access using things like certificates and identities. And the first thing generally when you do, your application will push out the kind of transactions that you want to do, and all that's defined in your contract, right? The smart contract. And it goes out to peer nodes, specialized peer nodes known as endorsing peers. And they would check and make sure that these are allowed and then respond to the application. And if all's good, the application would then send it to the ordering service, which is another node on the service. It's usually either one or a cluster of nodes that would operate this ordering service. So there would only be one, but whereas the peers would, you might have different organizations owning different peers. But the role of the ordering service is then to make sure that the transactions are kind of ordered in chronological order. And then once that's kind of done, it would then push out to all the peer nodes. And they call it committing peers, but really endorsing peer is also a committing peer, because each of them would actually have a copy of the digital ledger. And once that signal comes in, they would then write it to the ledger. So in order to make developing on Fabric a lot easier, a different project was kind of spun out, and it's actually called Composer. And it's kind of simplified how you would write chain code in a way that business users might kind of understand. So writing a business network really involves a few things, 4 components chiefly. So there is in a business network a model file which defines what the assets are. So they can be things like tradable items, so maybe records about fish that was caught from the sea. And then you have things like you also record the participants who's actually involved and the kind of transactions that you would perform on the business network. It looks a lot like JSON, but I'll show you an example later on. But it really isn't JSON. It just looks a lot like it. What really looks like JavaScript, though, it's actually the script file which contains the transaction logic. So if you are already an expert in JavaScript, this is going to be a no-brainer for you. Also, on every business network, there will only be one permissions file, so that controls access to the network. So it determines what you can or cannot do. And then sometimes we have this query file, which I personally have not actually used. And when you have these four kind of prepared, you would then archive them into a .bna file, which you would deploy to a Fabric network. And it can be a real Hyperledger, a real Fabric network, or it can actually run within a browser using an application called Composer Playground, where it makes use of your local storage in the browser to maintain that blockchain. If you wanted to give Composer Playground a try without doing anything, you can look at the IBM actually does provide this on their BlueMix platform, so you can try it out. But just know that whatever you do, make sure you export the relevant files, or once you clear the cache, or I mean, that's kind of it. You can use Composer Playground to interact with the Fabric network as well, and I'm actually going to show that later on if I have time. So quickly, how you would create your own Fabric environment. There are a couple of instructions out there. I'm just going to move along quickly. So one was from the Fabric website. There's one from Composer, and that's what I kind of lean towards and use in my own development environment. And then there's a sub-project called Cello, which their main purpose is to help blockchain operators to instantiate and manage their own on-prem blockchain. But these days, with everything going on the cloud, there is certainly a different option that you could look at. And so a lot of your typical cloud providers would have offered a blockchain as a service. IBM has their BlueMix, and they primarily provide the Fabric services. I haven't used them myself personally, but that's what they have. And Azure has, they're a little bit more platform agnostic, but I believe what they typically do is to help you kind of create VM templates. So they do have things like Ethereum, Hyperledger Fabric, some of the business ones we talked about, Quarter, and you have development environment, so you can actually get a VM with Truffle on the Azure cloud. They also have some of the single node ledgers that I'm not familiar with myself. Oracle, of course, is not left behind. They were a little bit late, I feel, in the game. But this is fresh out of this morning. I actually spun up a blockchain cloud service on a Tron network that we have. And it was pretty easy. You get this running in maybe under an hour. It's pretty simple to do this. Everything is just point and click. And they also have tools to kind of help you with chain code development and deployment. But I think what's really important is a little bit small to see here. They also provision a couple of nodes that expose the chain codes as REST APIs. And that as an Apex developer would be pretty important, because that's how Apex applications are really going to interact with the blockchain, the chain code, basically. Amazon, again, another latecomer, but I kind of want to talk about this because the templates that they created are very similar to how I've actually done it on the Oracle Cloud infrastructure. And this was before the blockchain products were announced, and I had to hand build some of these. So it's strikingly similar. I'll actually show that later on. Amazon also has something that's caught my eye recently. They work with Consensus, and they developed something that's pretty similar to Oracle Blockchain Service, where instead of managing a Hyperledger Fabric environment, you're actually managing a Ethereum network, and it's private. So it's another game changer that's really worth looking at if you're talking about industrial applications. So chiefly, what are the differences between blockchain and databases? Because like the databases that we know for a long time, blockchains also store some form of data. But the key thing is that blockchains are really designed to be immutable, whereas in RDMS, the data that you store in tables, they change frequently. Although you can design it to be immutable, but you have to design your data and your applications for that, whereas blockchains by nature are immutable. Robustness is really depending on how you define the word robust. RDBS, relational database, you have things like Oracle Rec, which gives you a certain level of robustness and rock solid performance. But blockchain, again, by design, because the data is kind of distributed across all the nodes, is very resistant to any failure. So that there's no real single point of failure. And when we talk about security, it's the same thing. Databases are secure, but you can also have internal actors who would fudge the data or do stuff with. Whereas in blockchain, in principle, would not be something that's subject to easy hacking. So you couldn't change something that's in the old records to make your own truth. It's a lot harder in the blockchain world. It is also by nature more transparent because anybody who is a participant of that network would be able to see what all the transactions that have occurred on the blockchain. Whereas in the database world, of course, we secure that, right, and keep prying eyes out of the system. Databases are generally controlled by a single entity, so whoever owns the database will control access and what you can do. Whereas blockchains, at least in the permissionless world, you're free to do anything you want in a sense, as long as you have a way to get in. In Ethereum speak, of course, you have to then have ethers to kind of do things. But generally speaking, blockchains don't have that central authority, because even in permission environments, participants may be from different organizations, and they each have their own access to the blockchain. One drawback about blockchains, of course, it runs very slowly, so it's not really suitable for transaction type databases. So you would probably be wondering a lot about blockchain, whether it's actually relevant. So here are a couple of points that you might want to consider. So as I said, the blockchain is not designed to be your single source of truth in terms of all the data in the world that you want to put in. In fact, you probably shouldn't, and put only stuff that's kind of relevant to be shared across all participants within the network. You would find yourself in a situation where many parties are involved. But here's what I find most interesting is that the people who are actually involved in those networks have what we call opposing interests. And they cannot be trusted, which is kind of contradicts what blockchain is being trusted. So it's a trusted environment for people who don't trust each other, to put it in a nutshell. And that's how blockchains by nature actually work. And if you have applications that require this immutability, then this is really for you. And again, as I said, if there are a lot of transactions that happen daily, you have to consider whether this is something that's going to be viable in terms of performance. Let's just think Bitcoin. I think at this day and age, it's been around for a good number of years, almost a decade. And today, if you were to do a transaction, it actually takes minutes before it gets validated and for you to actually receive any kind of Bitcoin. So I got interested in blockchains in early 2017. Prior to that, a month before, a group of experts actually published a white paper, because I was questioning a lot about its relevance to me, and how is this a sell to to my bosses, and I had to figure out and these are just some of the examples. Most of them are in the financial domain. I'm interested actually in the clinical areas, but it basically relies on an environment where there are things you need to kind of validate across different organizations. So things like real estate transactions, for example, and supply chain and all that. So I will not have time probably to complete both, but I'm going to try. So the first one is about Ethereum, and the domain largely is on something that we're kind of familiar with, and that's loyalty points. So loyalty points, as you would know, you would accumulate them, for example, through purchase of a product like airline tickets and things you buy in the shopping mall. But within a group of partner organizations, you would then be able to then sell this as well. And I kind of replicated this using the token. So ERC20 is the earliest form of tradable token. It's very simple. It's only got 6 functions and 2 events that you need to define in your contract. But it does have its flaws, and they've progressed right now to ERC 721, which CryptoKitties is based upon. That's one example, and I'm just going to quickly show what it looks like. So this site called EtherScan, it actually looks at all the, you can examine all the different transactions, and you can also look at the code. So that's Solidity code for you, and that's the contract for ERTC and the various extensions that they kind of built on top of it. The other thing interesting here is the contract ABI. ABI actually means Application Binary Interface, and if you're familiar with well, your PL SQL package specification, this is what really it is. It defines what the API is, and then you have things like Web3.js, for example, that it's able to then talk to the blockchain and use this as a way to build up a JavaScript API for you to interact with the network. So this is the application that I built, and I'm just going to show that to you and walk through some of the code, because I'll speed this up so that we can look at the second one if I can. So I have my loyalty store here. So one thing it kind of checks and makes sure that I have this MetaMask extension. You go to the site and follow the instructions, and do try and follow the links from this site, because there was a recent issue with phishing as well. So get the link from them. I've already installed the extension. I'm just going to enable it right now. I'm just going to close these. And when I refresh my page, it will then now detect that I have the extension installed. The only problem here is that I have not logged in. So let's try logging into MetaMask. So I pre-created my wallet, just so you know. So it's stuff that you probably need to do, and so once you kind of logged in, you'll see, oh, okay, we're good, but there's something missing. I don't have any Ethereum to expense. So yeah, it's true. So I'm going to switch to an address that a wallet that I've created on my blockchain. I've given myself a lot of money with. So that's my customer here, and once I've set it as my default wallet, I'll see them all good to go. So I can log into my catalog, use my super secure credentials to get in. And on this landing page here, I'll see, well, I got 980 tokens. And by tokens, I actually mean this. So there's a cute little site called Token Factory that lets you create a token. So you can, for example, create your own. I'm actually attached to my Ganesh node at this point, so I can do anything I want, right? Because I have a lot of Ethereum to burn. So I can say define what my new token is going to be and click create, and that would return me a contract address, which I can then interact with. So I'm just going to load that here. Okay, copy and paste skills are not very good. So now I've accessed my token. I can actually examine how true is this? Do I really have that much tokens? So I copy my wallet address and I can check my balance. And yep, it's true. I got 980, and I don't feel I have enough. So I'm going to ask the merchant to give me some more, maybe just 20 more tokens. So I have to switch to, again, interact with my merchant account. And now I can actually transfer. It will ask me to approve that transaction. I'm going to say yes. So now when I refresh this page, I'll see that oh, wrong account. So now I have 1,000, and I'm going to load all the way on the jacket. So I'll buy one of these with my points, but maybe not. It's a little bit expensive, right? So let me reject that transaction. And so none of that has gone through. Just prove it. I still have my 1,000 tokens, and I'm just going to buy something a little cheaper. It's going to cost me 20 for a business shirt, and I'm going to approve this transaction. So good. I've got now only 980. I think I must have clicked a little bit too quickly, but you can see that at this time here, I actually bought a business shirt, and I've used up 20 points. So how did I actually do this? So we'll look at the code for redeeming. So the magic actually just happens with a couple of important things, like a dynamic action that performs the interaction with a JavaScript library called Web3.js. And it does a few things, because we're going to first have to check that the required fields are there. But then once we have a handle on the contract itself, so Web3.js using the ABI that I talked about, given the contract address, would then be able to call it as a function. So here I give it the merchant address, and then the amount of tokens that I'm going to transfer from me as a customer to the merchant. And I, as a merchant, cannot blindly, because this client-side code, I cannot trust it fully. So this would have to then call a Ajax callback, which I, within the database as a merchant, would then validate the transaction and only approve it if all that goes well. So we'll look at quickly at the code. Oh, so here I'm actually interacting with the get node that, for example, or a Ganesh node that I'm interacting with, and I'm going to actually use this get transaction by hash API. So that call would have provided me the transaction hash that the user said they used to transfer the tokens to me. I log that transaction and then check with the service to make sure that that hash actually exists. And all of this is really just to get the transaction block and make sure that the hash actually matches here at the bottom. And if that all goes through, then we say that's good, and then we can perform whatever backend stuff that we need to do, for example, like updating your inventory and pushing out for shipment and all that stuff. So that's all the code that's really involved in getting the example going. Here's a little bit on the architecture that I designed, and it's pretty much the same as how you would design your Apex instance. The difference here is that we have this running as a Docker container, which only the database has access to, and yeah, that kind of protects it from any malicious actors from the outside. So these are in the slides for download. So they briefly explain the code that I just quickly went through, and this is just talking about some of the pain points you have when you're trying to work with Geth, because without that Web3 JS, because it's a lot more advanced. Whereas if you're working directly with the JSON RPC, it's a little bit more primitive in how you can do things and work with it. So the other thing I was going to talk about is a little bit about my past history. I used to work with a group that was involved in the sharing of biospecimens among researchers. And it involved a lot of ethics and a lot of training, public consultation. But the key thing is that I had to design a system that would kind of adhere to the ethics principles that we said we would follow. And that was that if a patient were to come for an operation, for example, to remove a tumor, the nurses, the coordinators at the hospital site would try and get some kind of consent in order to use that the data about the specimen for future research. And we give ourselves kind of 90 days and beyond, which if we don't get a kind of consent, then the data is actually anonymized. But we don't want to lose that data as much as possible. And this is how we used to do it with Java. And this little piece here was something that I thought about. You know, if let's say a patient one day were to come back, maybe they didn't give that consent at bedside and decided, you know, they really want to contribute research in some way, there has to be a way. And I kind of look at the Java messaging service. It's a publish and subscribe model, which I would use then to hash the personal identifiers and then maybe mix it up with some secret key. And this would kind of go out to remote applications and kind of flag for follow-up so that coordinators can actually look for those materials. I did a very early POC, but that didn't really make it into production because we are largely, as I said, governed by ethics, and all that has to go through it, an ethical review board. And I asked myself, you know, are there different ways to do this? Because I, as a you know, as I as a patient should have full rights to who I want to give data to, and I should always retain that right. And there was a group of people who came up with a technology that you as a patient basically store within your wallet, and there are different levels of encryption, but you would, using your application, then decide who has access. And that really kind of drove my interest in the blockchain in the first place. So this is the application that I kind of tried to mimic the that concept of a user being in control of who they want to show the data to. So I'm not going to show how to do Composer per se. They are in the slides, but I would show you what the Composer playground actually looks like, and this is what it is. So me pretending to be a patient right now. No, so first of all, I just want to go through this. This is the code. So it looks a lot like the model file I was talking about. It looks a lot like JSON, but it's not really JSON. And then we have the script file, which is purely JavaScript. And this is where all the logic for deciding, for example, like you know, whether the beneficiaries are added within a transaction. And then you have access control, which determine what a donor, for example, could do. They could have access to their own data, and they could also then add. So if I were to use this, look at the blockchain as another beneficiary, for example, like a research or a hospital, then this helps determine whether they can see a particular donor's information. So if I were to log in, for example, to an application that lets the customer connect, the donor connect, I can actually perform those transactions. So I can, for example, and just to prove this, I'm going to run the tissue network application as one of the hospitals. So right now, if I have to look at the list of donors, I'm actually not going to see any results, right? But using Composer, this is really primitive, but think of this as another web application, or maybe an application runs on the user's desktop. And I could then say authorize access to that particular beneficiary that I'm logged into. Submit this. Transaction has been committed. And now if I have to look at the list of data that I have, I actually have John Doe on my list of records to see. Just to show you the opposite, if I were to revoke access, now I no longer maybe able to see it. And for this, it's actually even simpler to implement. And really, all it does is just to interact with so I have a page process that then looks at the web service. So there's a full API which you can explore. I have a Composer REST Explorer here, which lets me see all the different APIs I can call. So one of them I call would be just to get the list of donors. So I make that call, but if I'm calling it as the beneficiary that's been authorized, that's all I'm going to get in the payload that's kind of returned. And I can look at it and maybe just grab the shared ID, which is the member ID. And in this case, it's really just an email address. And I store it in, let's say, in a collection. You can probably use the 18.1 features for this as well, but this was done kind of prior to it. So it's 5.1 style, basically. And in my query statement, I could then cross-reference the data that's in the database with what's in the collection and restrict what the beneficiary actually gets to see. So these are just steps that I kind of took to build up the network, all the various stuff that gets involved. With the slides, I think they'll give you some guidance if you want to try any of this on your own. In terms of architecture, this is how I've done it. A lot of it is Docker driven. So all these components, they're all Docker-based containers that are running on in the application a compute instance within my environment. I have one Composer REST server running for each of the beneficiaries, and that's because of the complexity behind setting up Composer REST service with authorization. But basically, I register the beneficiary with the URL that they get to call, so it's just difference by the rather primitive, but it's just by the port number. All this can be kind of simplified, and I'm just going to steal a few seconds to kind of show you this. We talked about the Oracle Autonomous Blockchain Cloud Service. So this is what I created this morning. And between what I showed you in that diagram and here, you really get to have a lot of fine-grained control on the node. So you have the peers on your network, the orderer, which there's only one, a CA, certificate authority, and a couple of REST endpoints. Here's where you would deploy a chain code, and as I saw this morning, you can also download a couple of sample code to help you get along. I'll just point out that I don't think it's cheap. This launches quite a bit of servers to kind of drive this. So just bear in mind the cost. But if that's an issue, just stick with this approach where you can stand up your own environment. So I'm just going to end and summarize with the very important point that blockchains do not mean just simply cryptocurrencies. They are involved with each other, but they're not the same. The key thing that us as developers should really focus on is the what blockchain actually promises to deliver. Smart contracts lead to DApps. We've focused a lot on smart contracts, and we talked about doing them on Ethereum, and we talked about them doing on Hyperledger Fabric. Blockchains can be permissioned or permissionless, and really depends on just the application that you're trying to write, where they should go. And there are lots of services that are offered by the cloud providers, so you don't really have to manage your own blockchain networks. You can make use of these. They cost money, but you save that in terms of man hours required to manage and stand up these environments. There are huge potentials across all domains, and really the key thing is for us to find what's the sweet spot. But I want to end off to say that everything that I kind of shown you today, the two examples, they're all built with Apex. So don't say that blockchain is irrelevant to us as Apex developer. It is very important. It's relevant, and someday you might come across that in what you do day to day. Couple of links which you can get from the slides later on. They are from IBM, but they're one of the leaders. So they have a good amount of content out there. You can get yourself certified with these cute digital badges as well. And there is actually a course on EDX. It's a online learning site that offers a full course on Hyperledger as well. And it teaches you on actually writing chain code. So with that, I'd like to thank you again for the 1 hour. I think we actually crossed them up, but I'm happy that I actually managed to show you the second set of code. And yeah, if you have any questions, you can ask them now. And if I don't get to answer them, feel free to stay in touch with me. Mark, I'm done. Are there any questions from the audience?
Yes, so there are a couple of questions, but as we're running out of time, most people are okay if we'll answer them by email, and we'll provide obviously the question and answer to everyone afterwards. But I guess we can go over a few of them. One of the question is, which programming language is used by beginners in blockchain?
It again depends on the blockchain technology that you're working on. So if you're, for example, working on Ethereum, their smart contracts are written in the
Okay.
Excuse me. They're written in Solidity. Other platforms like Fabric, they give you a bit more options. So you can write chain code in Go, for example, or Node.js, and that's basically JavaScript.
Good. All right, and let's take one last question, and then we'll send the answer for the other ones by email. But if you do have any question, don't hesitate, as Adrian said, to either ping him or you can write it again still in the question panel. So last question, when you mean at the beginning of your presentation, when you mean permissionless blockchain, do you mean as open source?
No, it means that anybody is free to join the blockchain network. So you can connect to it. You can do things on it. You can perform transactions without anybody first giving you a pass. So Ethereum is one example of permissionless. So as long as you can set up a get node on your own, you're hooked up, and then you can perform any kind of transactions that you want, as long as you have ethers to kind of consume. Whereas in a permission environment, so like for Fabric, you'd actually have to have a blockchain operator, an administrator of sorts, first create a card which usually contains a bunch of certificates and as well as an identity for you to connect to the network before you can actually do anything. And you are also what you can perform on the network is governed again by the authority on that.
Okay, good. Well, thank you so much for everyone for attending this webinar. And as we said before, we're gonna have a new one in 2 weeks. So watch your emails for the link and the question and answer for this webinar, and the new invitation for the webinars in 2 weeks. Thank you so much, everyone.
Well, thanks everyone. Thanks, Mark.